with SCAD, Savannah College of Art and Design. You've probably seen us down there. Savannah is obviously like the big one everybody knows, but we are also in Atlanta. Actually, we've got a location in France and an e-learning, so you can take courses online as well. I teach in Atlanta. My name is Professor Dodson, and I teach in interactive design and game development. Big long name. Really, it's about games, and it breaks down into a lot of different stuff. And today, well, first let me start off by talking about this idea of STEAM. Probably heard of STEM. Sometimes you may have heard of STEAM. And we throw the art into science, technology, engineering, and math. It's also the art. So STEAM, which is kind of cool because, you know, it invokes images of creating and making things, because that's actually what we do. We're designers. We're like the mad scientists. We want to make stuff, right? So people tend to think of this as an art school, and yes, it's an art school, but you know, the arts all goes back to actually creating something. So we're really about making something. In our case, in my case, it's going to be about making games. So we want to make games. So we've got to know everything about making games. We're going to focus a little bit more on the art side today as one part of it. We do a lot of, obviously, teaching that, but I just want to point out that the relationship here, you know, the process of iterative design that we use in game development and the process of development at SCAD and in the arts, in science and technology, has really got a lot to do with the scientific method and how to think like a scientist. We have to think a little bit differently, how to think like an artist or a designer, but it's a similar process in parallel. This kind of can break down into, from a game perspective, what we're really talking about is, hey, I have an idea, let me do some research, let me get a prototype together, something that I can test quickly. Maybe that's digital, maybe that's non-digital. And then let's get some people playtesting. Got whole QA departments at companies just for that, right? Get some playtesting going, get some feedback, find out what do we like, what works, what doesn't work, and then we go through that cycle again and again. We're going to focus largely, how does game art focus and play into this? So that name, Savannah College of Art and Design, right? Being a designer, I want to keep emphasizing that. Design kind of drives everything. So you have to have this idea, like, what do I want to make? And then I kind of know the art I want to make from it. Excuse me. So it starts with design. And we will do things like make maps. Often, you know, they'll get printed out, they get tested. You can actually, we have these cool whiteboards, like our tables are kind of like really big like this, but with, they may be this wide, and about 3 tables wide there. And it's a whiteboard, and you can draw ideas down there. You can take figures and whatever else we use for non-digital prototyping, get an idea together, figure out how the mechanics work, what's fun, before you ever touch the computer. Because that's really important, to not be solving technology problems when you're trying to solve design problems. Before you know it, you're trying to look everything up. How do you make this code work? How does this thing, it's not doing what I want it to do? And, oh, let's just redesign the game because I can't make this do what I want it to do, so we'll just do it this way instead. Now the technology is forcing the design instead of the other way around. So we like to make sure the design drives everything else. We actually do make board games, prototype with those, and it teaches like the principles of design. What makes a good game? What makes a fun game? We got a huge game lab full of board games. We'll get those out, we'll play some different board games, show different mechanics, how things work. We do a lot of documentation also. So maybe game flow charts, design documents, things like that, where when you work with a team, you got to be able to show the people on the team, how's this work? What are we doing here? Okay, go read the design documentation, look at the flow charts, look at the prototypes. That's what we're going to make. From an art side, the artists are doing a lot of their own research into visuals. So, you know, we have these art history classes, and a lot of what you take at SCAD are a lot of foundational art history classes. You might think, oh, I got to take all these art history classes. But what you're learning is you're researching for what has art been through the centuries, and knowing we have art from all cultures that we learn about, right? And then you go and you say, well, all right, what do I want to bring to my game, or from an art direction perspective? What do I want it to look like? And you do that research and you build on that. You get your ideas, and then you start coming up with, what's that going to look like? How am I going to take that architecture, and how am I going to build it into an actual game level? And so you work on your game flows and your maps and things like that again. And then you start working out your floor plans. Where are things going to be? Key codes here. So we're coming up with a plan so we can go into the game engine later and build it. We're going to need some concept art. So let's work out a concept. What is the game going to look like when we're finished? What is the vision of this game? Okay. So the designers are working out the maps. Here's how it's all going to work. We've done some research. Now we'll turn it into concept art. And everybody's going to work on concept art. We use Photoshop a lot for concept art. And then we move into a 3D modeling program. The artists are going to now take this concept art, and not everybody does everything. Every one of these slides that I'm going to show you is a different job. There's so much that goes into making a game, and so many people are needed, right? One person might be a concept artist. Then we have somebody that's an environment modeler, and what they're doing is they're going into a program like Maya. Blender's one you may know because it's free, so if you want to start messing around with 3D modeling, you get Blender. But you're going to build out just this gray, no textures or surfaces or anything like that, just this grayed out vision in what we call polygons. So you got all these little tiny shapes that are all making up. You can't see them here, but we'll see some examples. And okay, good, so we've built it out, so now we have what it's going to look like in 3D. We also have some advanced modeling classes that we teach. So when you get into something like, the thing is, in a game, you've got your polygon count, and what that means is, we've got all these little things that have to be rendered. And the rendering engine, of course, is the thing that makes you see it. You can see the game on your computer screen. And so that takes time. Nobody likes game lag, right? So you've got settings in your game. You can turn really high up or low to make, depending on how well your computer works, to make it perform better. And all these things there are a lot of things that affect that speed, but one of them is your polygon count. So we want something to look really cool and realistic. We have to have a lot of polygons. So in this case, this is a program called ZBrush, where you're actually traditionally taking more like a sculpting clay, and you're going to move the brush, because we use these computers called Cintiqs for our artists, which you're actually drawing on. So you take your tool and you're like sculpting now, 3D. You're moving this thing around, actually sculpting like that. Some of the virtual reality that we're moving towards, we don't have a lot of this now, but the future is going to be, I've got my gloves and my VR headset and I'm sculpting like this, right? But right now it's still sort of like a tool, like a pen tool. We have millions and millions of polygons now, right, to make this level of detail. Problem is we can't really use that in the game engine. So we'll later look at a technique. It's important to know how to do this because we're going to go from a high polygon to a low polygon process. We're going to do something we do in games all the time, smoke and mirrors, we fake the look. All these little technical tricks. And we get into what the skill of an artist in game development is often known as technical art, because it gets very technical, knowing how to technically do these things, but it also requires the eye of an artist. Now, you have this 3D model, and we've just seen gray models so far. So how do you get paint on it? How do you get it to look cool, what we call a texture? Well, all these textures, if you go on your computer, and looking at your files, you're going to see little, if you bring your images up, you're going to see these little square boxes that are flat. Well, that's what goes onto a 3D model. When you're downloading the new game and it's taking forever and there's stuff that you're downloading all these texture files amongst other things. And those texture files are going to attach up to the 3D models, and they're going to wrap around in some way the 3D model. And that's done by a process called UVing. And UVing is really basically, it's like every one of these little things is a polygon. So what we're looking at is how do we sort of think like paper, like origami in reverse. We got to unwrap this 3D model and flatten it out. And then we can paint in all those areas, and we know, okay, that's going to be the head, that's the eye, that's the hand, and then they paint that way. Now, fortunately, this has gotten a little easier. There's a program now called Substance Painter and some other tools like that, where you can actually paint as if it was a clay sculpture and you're painting onto it. But it's still going to flatten out and map it like this. So some of these techniques are automated, but they still require the artist to get in there and understand what's happening and be able to modify this if necessary. So it's the whole process for, you can see the green lines of this character. Basically, we're making little seam lines, and we're kind of taking our 3D paper doll, if you will, and folding it out flat. And then that's how they're going to paint onto it. So once you've done that, we look back at our high poly example where we had a lot of detail. Maybe you do that with a character. And we start out with this low poly version, right? We've got a low polygon version here. We can see the polygons. They're little squares. You can see all those little squares in there. And it gets mapped. The UVs are made. And then there's a process where we can make the camera kind of smooth it out a little bit. We call softening normals. These things are called normals. It gets a little bit technical. But basically what it does is it makes it look a little smoother and not so blocky. But it still doesn't look the realistic style that we want it to look yet. So we have our high polygon character, and we basically take that same process and we kind of unwrap the modeling image on him and flatten it out. We get what's called a normal map. And this normal map is basically a way of taking this high polygon looking look and flattening it out, and then wrapping it onto this lower polygon version, and it fakes the illusion that it looks like that, but it doesn't really. It doesn't have that many polygons. So we're faking a high poly look. So we're getting a high resolution look out of a low resolution model. So this is like the whole field of understanding technical art. This is a little bit technical what I'm talking about. There's technology involved. There's a process and a pipeline, understanding how all this works, and how are we going to work friendly with the game engine, because nobody wants the game to lag, and it's got to not take forever to download and play. So all these things, the artist can really, good art, really nice looking art, can really slow a game down. So the artist has to be aware of these things and how to solve these kind of problems to make the game run efficiently. The actual skin, we call it skin, you can see over there, it's still a flat texture, but it's been flattened out like this, and that's what it would look like flat. It's still a texture file that gets basically wrapped all around this character and makes it look like, okay, now we have color and it's all painted. So different flat texture files that all wrap on and they layer up to create all kinds of interesting effects. And that deals with our surfacing, dealing with the surfaces. So we had our gray version, and now suddenly we're making it look like they're stone with some of those techniques, and they look sort of 3D, but they're really not, right? And this is all done through textures, shaders, and shaders are just a way of having the computer do some code and what we call visual effects. I'm sure you probably know a lot from movies. Making things look cool in movies is all about visual effects. But we use those in games as well. And so taking those shaders, taking that code, and doing something with the textures and integrating it all together and learning all of that field, which is also technical art, then suddenly makes everything come to life and look really cool. Another aspect we have to consider, especially for our characters, is how is this thing going to be animated? So obviously when our characters turn around, we have a whole animation school, but that's mostly for film, but you can apply it to games as well. We have some specializations in our game major just for game animation. But process of animating and all those skills they learn in the animation department are all about what we call, for us, it's really important to have this idea of rigging. And rigging is where we take this sort of skeleton and then we attach it, these bones get attached onto our character. And then that's actually the thing that is moving and animating, and it makes the model that we made sort of follow along. A lot of ways to do animation now. We have a motion capture lab, so we get into the suits and run around and do animation that way. But then you've got to map that animation onto this character and make it move. Rigging is actually its entire own job. Rigging is a big deal. You can rig, a good rigger, you can get a job just doing rigging. It doesn't sound very exciting. A lot of people think they're going to be necessarily a rigger, but sometimes these things you find that you like something you didn't even know was a job, and suddenly everybody wants to hire you because you're a good rigger. Now eventually we got to get into the game engine. So we use Unity and Unreal to teach both. And Unreal focuses very much on visuals. I mean, both of these engines do everything, right? But from the start, out of the box, Unreal was a little better visually, as traditionally known, and Unity's a little bit better at getting some sort of like a rapid, quick game ideas together. The engines are getting more and more influenced by each other, and so that becomes less and less true. They're more and more where if you know what you're doing, you can get something going pretty quickly. But they're two very popular engines, and different studios use different things. In Atlanta, Hi-Res Studios uses the Unreal Engine, and Tripwire uses the Unreal Engine. So those two studios in Atlanta. There are a lot of small studios that use Unity. So we just teach both. It's good to know both. And this is where it comes all together. It's pipelines now, all these things along the pipeline, in different pipelines are all coming in together. And then once we're in the engine, now our shaders become a big deal. So the shaders are something where imagine this is just a flat sphere. Like there you see it's a flat sphere with some different effects like that. But all of a sudden we're using different kinds of mapping and shaders to create these different effects. So we have, suddenly it looks like 3D, suddenly it looks, this is a really good example of making something look 3D. We're mixing our textures, our flat image files together with some code and some other effects like that. And kind of hooking up a bunch of different spaghetti network stuff. It's visually what it looks like along the nodes. And boom, suddenly we have a cool look. We end up with things like, you know, the look of Borderlands, and that uses something called post-processing as well, which we'll get back to. So, but these are things that now, that we're basically doing once we've gotten into the game. So now we have to have an artist that is a technical artist, really a technical artist, that understands visual effects, how to make shaders work, and we have classes on that as well. And that's just one person's job too. Lighting is a big deal. So we also have, you know, when you just open up a game engine, it's all dark in there. 3D modeling program, there's nothing. So you have to light it. And lighting is this whole other thing. If you're watching a Pixar movie, you're going to see like in the credits, like lighting, boom, 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 a whole bunch of different people doing lighting, right? A lot of different kinds of lighting. Games have a lot, they're getting more and more advanced how to do it faster and more effective, but still it's a skill. So those are done in the game engine. Another thing, kind of going back to our visual effects artists again, all these things are game tech artists kind of things. Particle effects, so if you've ever seen like an explosion or fire or smoke, all that stuff like that moving around, those are particle effects. And particle effects, they're done in their own editor, and then they're brought into the game. So we have a class where we build that. One example, one of the things we do in one of our advanced classes is we get into like spell effects, right? Where if you ever play a game with a spell, there's usually all kinds of visual particle effects. It has to be worked into the code. How does the game mechanics work? How does this work with animation? It all ties together. It's a very game tech thing. In post-processing, sometimes what works best is just to have a camera. We have some code. We say, hey, change the way the camera sees the scene. And you can, this actual shader there is an example. So this idea of this black outline around everything, you know, if you just tried to paint that onto a character's arm and turn around, you would see a black outline. But you want it to where no matter what way the camera's facing, it looks like a black outline. So it looks like a cartoon or a drawing, right? So that's an effect like Borderlands uses, and that's all done for post-processing. We do teach code. Certain of our, in the beginning, very much in the beginning, we'll sometimes teach visual coding. So when we're talking about these little nodes, and you may have used Playmaker, it's visual scripting for Unity. This is just really right in the beginning. Unreal has a blueprint system where it's visual scripting as well. So we're teaching people that are more design-minded and art-minded how to get their prototype working. And we do move in Unity pretty quickly in our beginning, in our core principles of programming class, we call it. We start teaching C#. So that's the language Unity uses. We do that pretty quickly. So we do teach programming. Okay? We do it more from the perspective of a designer trying to make the thing they want to make, or an artist trying to get their art to work in a certain way inside the image. We also teach the Unreal Editor. The Unreal Editor starts out with its own various different kinds of games, and you can mod from there. You eventually get to the point where you can start from scratch and build your own, which we do teach that. But a lot of this idea of modding, right? Different mods. Well, you start with the game idea. And so Unreal's gone to the point now where they just have all these templates that you can draw on, and you go start with that template, and that's where you build. And then you got to know how to mod and program and mess with the game. And you still have to know all this technical stuff. But we're really talking like a designer. Hey, I want to make my game work. And then you learn programming along the way as you learn what you need to make your idea work. So it's a little bit of a different approach than a software engineering school uses. We experiment with a lot of different technology. Get into VR and AR, different headsets and things like that. We have a game lab where we tinker around with stuff like this. Some of our projects that we've had at SCAD. We have one group made this pumpkin and banana game. So you're actually controlling the game. It's like an asteroids game, and you're controlling the game with the pumpkins by touching the pumpkins. And it rotates the thing around, and the banana actually makes the shield go up. It's all this really interesting idea. So it's fun because everybody has to control the different thing and all work together, touching the pumpkins and the banana. It's pretty crazy. So we experiment with AR. We've done several AR games. One of the ones that got most recognition was a zombies game called ARG. It's AR. And basically you look through a phone, and down at this flat map of what you see through the phone is a whole city, and you're zooming in on little zombies walking across the street trying to, kill poor citizens or whatever, trying to blow up the zombies. You're in the helicopter, is your idea, right? So we're flying around the helicopter. You're in the helicopter side. Prisma was a game that was done as a senior project, and the team got together, went and kickstarted the game, and got that game kickstarted and started their own studio. We find Prisma out there. Robot Beatdown was a VR game where you run a mech in VR, so that's pretty cool. It doesn't translate as well here looking at the screen, but that's kind of your view. It's pretty cool when you're in VR running around in the city in a giant mech, like Pacific Rim style. This game, Battery Jam, was actually it's on the Switch. So this was one that a team went through an incubation sort of process, made their own company, and got it onto the Switch. This went through a lot of evolution and iteration, and it's a fun little game. That came out as a senior studio game as well. It also won, some of these games have won an E3. If there's an E3 student competition, we always have students try to enter it. Their senior studio projects, and sometimes they've actually won. We've won several times actually. Mobile game, Marshmallow Mayhem. You run around as a little marshmallow, so we do mobile games as well. And this is when you're a little marshmallow and anything hot, and expand the marshmallow and make you stick to stuff, and then cold shrinks the marshmallow. It's kind of collectible idea. But that team went on to form their own company. And they made a game, published a game called Print Snap recently. And I think it's on Facebook and some other things like that. But Kerchunk Games, and those SCAD students, they're all working around Atlanta right now. Okay, so that's my presentation. have any questions? Yes, quite a few. I've never worked on, I don't do AAA, I've typically worked on indie stuff. And one of the things about teaching, right out of grad school, I got hired teaching. It wasn't my plan, but I found that I enjoyed it and I got a job doing it. So I mostly work on indie things on the side. And I actually work on some of my indie projects, and some of the crazy stuff I'm involved in. If you ever heard of live action role playing, for years I had a live action role playing game company. Actually, my first job out of undergrad, I worked for a tabletop game company. So I got really experience with a non-digital background version and kind of saw the world go into digital video games. And I did that for quite a while. Then I started doing some of that with consulting and working with companies on narrative and developing their role-playing game systems, since I had experience in that. That led into grad school, and since then I've just worked on all kinds of various stuff. I've done some contract work. So I've done things that you can do while you teach, which is not going in 60 hours to a game company working all the time. But yeah, I mean, I can show you a list of stuff I made at some point. Not about me though, but I appreciate the questions. Other questions? Anybody thinking about going to SCAD? All right, cool. Hope to see you there. It's a cool place. So I just want to point out that if you think, oh, it's just an art school, I hope the layout showed you that, yeah, we do focus on art a lot, but there's a lot of technology and a lot of design that goes into it. If you want to work in the game industry, it's a good place to go. And if you want to go, there are plenty of good schools to go and learn. But, you know, just get out there. There's a lot of stuff you can do on your own if you're interested in games. If you can get Unity and Unreal are free to download, you can start learning those on your own. There's so many videos out on the internet. If you want to learn about how to do this stuff, there's a lot you can learn on your own. And the advantage of college is you're going to get to work with teams. You're going to have a lot of students around you, a lot of support. You're going to learn from professors who've been doing it for a long time. You get a little bit more one-on-one. But yeah, just encourage you to go out there and learn. All right, any other questions? Okay, thanks.